Today we're going to be looking at absolute value functions. This is section 2.7 in your book. It goes along with these three benchmarks, which are listed on the curriculum map for the county. Your objective is that you will be able to graph absolute value equations. We're going to begin by looking at the parent function. The parent function is y equals the absolute value of x. If we begin by making a table for the parent function, we're going to pick some x values. Let's start in our negatives and let's go up through the positives. Okay, so we have 3 negatives, 3 positives, and 0 in the middle. If we plug these numbers into this function, we get the absolute value of -3 is 3. The absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. And you see here in the middle of our table, at 0, 0, our y values repeated on either side of that on either side of 0, 0. This is going to be called the vertex, or the center point of our graph. Because now if we take this table and plot it on the graph, we get 0, 0, -1, 1, -2, 2, -3, 3. And then on the other side, we get 1, 1, 2, 2, 3, 3. And as you see, 0, 0 is kind of the center of where all that stemmed from. So this is called the vertex. Going through that vertex, why we have a mirror image happening on either side, going through that vertex, we have what is called the axis of symmetry. And it is an imaginary line that runs through our vertex so that whatever happens on one side equally happens on the other side, which is what creates this V shape on our graph. So if we were to continue on and do -4, 4, then the same thing would happen over here at 4, 4. And every single point will have a reflection over that axis of symmetry running through the vertex, which is the center of the V shape. Okay, so let's look at some vocabulary words. So the absolute value function is the graph. The graph is a V shape and symmetric about a vertical line. That vertical line is called your axis of symmetry. The bottom of the V shape is called your vertex. So every graph will have 3 components to it: the vertex, the axis of symmetry, and the V shape created from the absolute value. Let's look at some transformations. We're going to first start with graphing vertical transformations. Vertical transformations run up or down. If you copy the chart from the bottom of page 108, this goes with the translation of y equals the absolute value of x plus k. K is going to tell us to go up if it's positive or down if it is negative. We always start with the parent function. So here's an example. Y equals the absolute value of x plus 3. This plus 3 is going to tell me to take the parent function and shift everything up 3 units. Okay, so here's a graph with the parent function already on it. Here's our 0, 0, 1, 1, 2, 2, 3, 3, and so forth on. So now what we're going to do is we're going to take all of those, we're going to start with the vertex, and our vertex is going to move up 1, 2, 3 units. So now, instead of being at 0, 0, our vertex is at 0, 3. The other thing we're going to talk about, if we look at the parent function, it has a slope of up 1 over 1, up 1 over 1, and it continues that pattern. Because there's not a number in front of x, then this also has a slope of up 1 over 1. So from our vertex now, we can go up 1 and to the right 1. Once again, the axis of symmetry runs through our vertex, so that whatever happens on one side equally happens on the other side. And then once again, we can go up 1 and over 1 one more time. And then this also has a reflection on the other side. And there our V shape is created by taking the parent function, or the vertex that was at 0, 0, and shifting it up 3 units. Let's look at another example. So now we have the example y equals the absolute value of x minus 4. This time, the minus 4 is going to shift down 4 units. So once again, we can start with our parent graph, or at least you need to know that the vertex always starts at 0, 0. Then we're going to shift that vertex down 1, 2, 3, 4 units. So our new vertex now is 0, negative 4. And our slope still being 1 over 1, because there's not a number in front of x. 1 over 1. And then once again, we have our axis of symmetry running through the vertex, creating a mirror image on the other side. So when we went up 1 and to the right 1, we also need to go up 1 and to the left 1. And same thing, one more time, up 1 to the left 1, so that every single point has a mirror image. And then we connect our dots to the end of the graph. And there is our V shape. So on page 108, I would like for you to try Got It number 1A. Pause the video, write the problem down, try it, and then when you're ready, check the answer in the back of the book to make sure you did it right, restart the video, and continue with the lesson. So now let's look at graphing with horizontal translations. Horizontal translations take us to the left or right. This one is defined by the letter H, which this time will come inside the absolute value. When we did K, notice that it was a plus K. So positive K took us up, negative K took us down. This time, it's a minus H, which means that everything is going to be done as opposite. So if it's a minus H, we're going to go up, or to the right, and if it's a plus H, we're going to go to the left. So let's look at some examples. We're going to start with y equals the absolute value of x plus 2. As I said, horizontal translations are always as opposite because this is supposed to be a minus. So to get a minus, we look at this function as being the absolute value of x minus negative 2. So that minus a negative is what makes the plus sign. So instead of going to the right 2, we need to look up here and think that this was a minus 2 to make the positive, and we need to be going to the left. So let's start with our parent function. This plus 2 is actually going to take us left 2 units. So take our vertex, which is at 0, 0, and we're going to shift to the left 1, 2 units. Once again, since there's nothing in front of x, our slope is still 1 over 1. Up 1 over 1. This time, our axis of symmetry has shifted with our vertex and is now running through the vertex at -2. So that once again, whatever happens on one side of the axis of symmetry is equally happening on the other side of the axis of symmetry. Draw our V shape. And now we have a graph that has shifted left 2 units. So when we're looking at this, we need to always remember that inside is as opposite. So let's look at another example. This time, let's look at y equals x minus 3. As I said just a minute ago, inside is always as opposite. So this transformation of 3 is going to take us to the right 3 units. So if we bring up a graph with the parent function on it, we're going to take our vertex, and this time we're going to shift the opposite of -3, which is going to the plus side of right. 1, 2, 3. And once again, there's nothing in front of x yet, so our slope is still up 1 over 1. Up 1 over 1. Our axis of symmetry shifted with our vertex and is now running through at x equals 3. And then we have a reflection of those points happening equally on the other side, creating our V shape. Once again, I would like you to try one yourself. So turn to page 111 in the book and try number 13. That answer is in the back of the book since it's an odd, and when you're finished checking your answer, restart the video and continue on with the lesson. Now let's look at graphing a stretch or compression. A stretch or compression comes from the number in front of the absolute value. We use the letter A to define it. This is what creates a different slope other than 1 over 1. If the A is greater than 1, it is a stretch. If A is between 0 and 1, it is a compression. And the last thing, if A is negative, that is a reflection. And we'll look at some of those. So let's start by looking at a stretch. Y equals 3 absolute value of x. Once again, we're going to start with the parent function. Since there's nothing added or subtracted inside and nothing added or subtracted outside, this function is not going to shift up or down or left or right. Our vertex is going to stay at 0, 0, and our axis of symmetry is going to run through there at x equals 0. So get in the habit of every time you make a graph of listing what your vertex is, which is 0, 0, and your axis of symmetry, which is always going to be written as x equals, because it's a vertical line running through the x-axis. If it shifts right, it's running through the x-axis over here. If it shifts left, it's running through the x-axis over here. So this one, since we're running through the origin, it would be x equals 0. Now, because we have a number in front of the absolute value, as I said, this is going to act as our new slope. Because that number is greater than 1, it's going to be a stretch. So we're going to stretch by a factor of 3, which means from our vertex, we're going to go up 1, 2, 3, and over 1. And you can do it again if there's enough room on your graph. Once again, your axis of symmetry acts like a mirror, and this has a reflection on the other side. There's our 3 points to create our V shape. And as you notice, this V got skinnier than the original parent function because it has been stretched upwards. Now let's look at a compression. Y equals 1/4 x. Because 1/4 is between 0 and 1, this is going to be a compression. And once again, it's still acting as a slope. So we take our original parent function, and because there is no addition or subtraction inside or outside, our vertex stays at 0, 0. And now our slope becomes 1/4. So we're going to go up 1, but right 1, 2, 3, 4. Axis of symmetry still running through the vertex at x equals 0. So this graph still has the same vertex and axis of symmetry as the one before. But what changed is the slope. I went up 1 and over 4, and then I reflect that onto the other side. So I go up 1 and left 4, and then this time I make my V shape, and if you notice, instead of stretching up and getting skinnier like the first one we did, it looks like someone sat on it and it got flattened out. Once again, here's a problem that I would like for you to try on page 109. Please try got it 3A and 3B. You want to look at the answers in the back of the book to make sure that you're doing it correctly. If you're not, write down questions and bring those into class tomorrow. When you are ready and done with your answer, please continue on the video. Alright, now let's look at putting it all together. We'll be looking at a graph with multiple transformations this time. So let's start with this equation. The transformation equation, or what they call general form, looks like this. A is going to be your stretch or compression. Remember, it's a stretch if it's greater than 1, a compression if it's between 0 and 1. H is going to move you left or right, but as opposite. So if it's a plus, you go left. If it's a minus, you go right. K is going to tell you to go up or down, and we keep that one as is. And what that means is if it's a plus, it's going up, just like you think. If it's a minus, it's going down, just like you think. It's not like the opposite with the H over there. So if we look at this equation, the first thing we need to do is identify our vertex. The vertex uses the letters H and K. They are your transformations. From 0, 0, where are we going? The plus 2 is going to tell me that I'm going to go left 2 units. The plus 3 is telling me that I'm going to go up 3 units. So if I take my graph where the vertex was at 0, 0 and go to the left 1, 2, and then up 1, 2, 3, my vertex now falls at -2, 3. Notice that it is the opposite of H and K as is. This will always be true for your vertex. Now let's look to see, do we have a stretch or compression? Is there a value of an A in front of X? No. So that means that it is a 1 over 1. So from my vertex, I'm going to go up 1 and over 1. Up 1 and over 1. My axis of symmetry is going to run through my vertex. Remember that it is always x equals because it is a vertical line running through the x-axis. So my axis of symmetry is at x equals -2. And then it acts as a mirror to reflect these points on the other side. So I have a point here to match this one, and I have a point up here to match that one. Then from my vertex, I can connect my dots and make my V shape. So once again, here's another problem I would like you to try. Turn to page 109 and try Got It number 2. The answer should be in the back of the book. When you've checked it and you're ready to move on, press play and continue on with your lesson. We have one more slide to look at. All right, the last slide is without graphing, we're going to identify the vertex and the axis of symmetry and describe the transformations of the function. So let's look at this example. The first thing we want to do is identify that vertex. That vertex comes from our transformations, which is going to be here and here. Once again, this is always as opposite, telling me to go to the right 6 units. And this is as is, telling me to go up 8 units. So my vertex becomes 6, 8. I move to the right 6, which is positive, then up 8, which creates the vertex. Next, let's look at our axis of symmetry. Our axis of symmetry is always going to be x equals, and it's always going to match the x value of our vertex. Since our vertex was 6, 8, then our axis of symmetry becomes x equals 6. Last, we're going to use the chart on page 108 to describe the transformations. If we start with the negative, we're going to say the function has a reflection in the x-axis, and what that negative is going to do is take that V shape and flip it upside down. So it reflects over the x-axis, and instead of going up, it's now going down. The 1/3 is a compression. So then we continue on by saying is compressed by a factor of 1/3. So we always use that number to tell how was it compressed. It was compressed by a factor of 1/3. Now we move on to our -6. As I said earlier, our -6 is going to take us to the right 6 units. So we continue on and say is translated 6 units right. And finally, we get to our last number, which is the +8, which is going to take us up 8 units. So we finish off by saying, and translates 8 units up. So when I get done, I have a single sentence explaining the transformations. The function has a reflection in the x-axis, is compressed by a factor of 1/3, is translated 6 units right, and translated 8 units up. You may abbreviate, but do not be lazy and make a list. It needs to be written as a complete sentence. And then you also need to have on there your vertex, which is at 6, 8, and your axis of symmetry, which is x equals 6. So in a question like this, I would expect to see the vertex, the axis of symmetry, and a sentence describing the transformations. So turn to page 110 and try Got It number 4 in the book. Once again, look at the answer in the back. If you get it wrong, bring questions in tomorrow to class. And that concludes your lesson for today. Make sure that you print out the assignment that goes with it, try the problems, and bring it into class so that you may ask questions.